So this is the transformations of the mother function f of x equals x squared. And first we need to talk about what she looks like. And I call them mother functions. Most people call them parent functions. But we're just going to make a small table. I teach the way most people teach. They teach a three-point technique. So we're going to plug in a -1. If you plug in a -1 to x squared, -1 times -1 is 1. We're going to plug in a 0. If you plug a 0 into x squared, you get 0 back. We're going to plug in a 1, 1 squared being 1. Again, three-point technique. The mother function f of x equals x squared contains the point 0, 0, 1, 1, and -1, positive 1. And it looks like a parabola. Most of the time we just say the letter U for kids to get it to stick. That's the mother function. And we're going to transform it using this, the general transformation form for a quadratic. And it's a times f of b times x minus h, quantity squared, plus k. Now a is what we call the vertical stretch or compression. It's also known as scale factor. That's something you'll hear as well. If the absolute value of a is greater than 1, it's a stretch, which means it grows faster, it gets taller. If a is negative, it is a vertical reflection. It's been flipped upside down. It's now a parabola that opens down. And if a is between 0 and 1, something like a fifth, a half, a quarter, it's what we call a compression. And the funny thing is, and I wish I had some Play-Doh for this, but if you can't imagine Play-Doh, you had a bad childhood, right? If you took some Play-Doh and pushed down, that would be a vertical compression, but at the same time you're making it wider. It's the same as a horizontal stretch. Speaking of horizontal stretches, that gets us to B. B is what we call a horizontal stretch or compression. Now, it works opposite of A. So if B is a number, a fraction, it's a horizontal stretch. If B is a whole number greater than 1, it's a horizontal compression. If it's negative, we have what's called a horizontal reflection. It's flipped like that, which is kind of interesting. And I've got a little note over here. It says, no, B can almost always be worked out and turned into A. And that's how I approach things when I teach Algebra 2. If we see a B, okay, don't worry about it. Don't sweat it. We'll figure out how to math it out of there. Get it out front where it's easier to work with. All right, H is what we call a horizontal translation. It shifts it left or right. And I talked about this the other day in a video. Why they pick the letters H and K, I don't think anybody truly knows. I don't think they do. Just probably leftover letters. There are some people who've thought maybe it goes back to some Latin terms and some stuff like that. K is the vertical translation, shifts it up and down. A little side note here too, that x equals h is always the axis of symmetry for a quadratic. So here's my first example. It's f of x equals -2 times x plus 3 squared minus 1. All right, so let's talk about A. A is -2. The negative implies a vertical reflection. So it's not going to be a parabola that opens up, it's going to be a parabola that opens down. Now, you talk about the absolute value of -2. That is going to be bigger than 1. So this is a stretch. Okay, this thing is taller than Mom. Now, you'll notice here that I've got off the side, it says think initial slope. The initial slope is to fall, because it's negative, 2 units as we run 1 unit left or right. A lineup process here tells me that this is h because this is the x minus h piece. So h is not 3, h is -3. I'd say 1 in 3 kids has a tendency to just want that to be whatever sign they see. And it's pretty bad. And it doesn't seem to matter that if they get it one day, they just kind of revert the next day. I'm not sure why that is a problem, but it sure is. So this thing has been translated down 3 or shifted. And we have a k value plus k equal to -1. So it's also translated down 1. And I like to draw these things in because it actually shows you know what's going on. So I do like to draw these in. A lot of people do not, but I do. We're going to translate this thing down 3 units. I'm just going to start there. We go down 1, 2, 3. And I don't know why that says down. That shouldn't say down. I guess I was having a brain fart. Left 3 because it's negative. Left 3 units. And I don't know why I went down 1. Ooh. Oh. This video's not starting off so hot, is it? It is translated down 1 unit. That is correct. Big check mark there. And we are left 3. Not right 3. Left 3. And this, boys and girls, since this is a parabola, this is my vertex. My vertex is at -3, -1. H and K are the vertex of a parabola. Yesterday I did a video about vertex form. Today I'm just talking about general transformations of the same thing. All right, now moving forward here, let's talk about A. A is -2. That means we have to fall 2 units as we run 1 unit to the right, and we have to fall 2 units as we run to the left. And then we're going to redraw a parabola, because that's what these things look like. Anything with a square as an exponent looks like a parabola. Just shapes. And you know what? While we're at it, let's do some things and talk about like domain and range. This parabola runs left forever, which means it runs to all the negative values. It runs all the way to what we call -infinity. And it also runs to the right forever, so it's running to positive infinity. Its range, which is our y values. The lowest y value is down here. The arrows are saying fall forever. Is at -infinity, and the high y value is at -1. Now the reason I'm using a bracket here is because I have equality. I have a nice solid dot. Anytime you have a solid dot on a graph, it's going to be a bracket. If you're not a solid dot, you're going to be parentheses. And that is our first one. I'm only going to do 2 today. That's all I'm doing on this one. I want to address this, where we can turn these horizontal stretches into something else. So, I'm not going to do a whole lot, just 2 of them. Keep the video nice and short. So let's make up something that looks like it might be an intimidating little function, but is not. Let's put fractions in it. Yeah. So f of x equals, I don't know, let's do a -1, let's do positive 1/4. Last one was negative. We already talked about the reflection. Positive 1/4 of, let's put a 4 here. 4 times x plus 1 all squared minus 3. Now, let's go through and talk about the pieces, and then I'll show you how to work it out and make it not as bad. So if you look at this thing, it says A is 1/4. That means that we are compressing the graph, but as you push down on some Play-Doh, it gets wider, right? So a vertical compression is the same thing as a horizontal stretch. But A is 1/4. That means we are pushing down, but the initial slope is to run. Hold on, let me change that. To rise 1 as we run left or right 4. No, that's not what initial slope is. See, I did that on purpose. The thing with initial slope concept is you got to realize it's over the 1. So I purposely made a mistake there because it's something that kids do when they see things as initial slope. They go back to how they were taught in 5th and 6th grade. You know, the early levels, rise 1, run 4. It's rise 1/4 as we run 1 left or right. That's the only issue I have with using A as initial slopes. Kids sometimes mess it up. All right, now B is 4. And B is one of these things that a lot of people just don't like. And I literally try to work it out. And you can almost always work it out. B is 4. This is actually a horizontal, not stretch, compression. Now, imagine if you had some Play-Doh, and I wish I had some Play-Doh, but if you had a piece of Play-Doh that was this wide and only about this tall, if you pushed in, if you horizontally compressed it, the height would turn around and get bigger, wouldn't it? That's how it works, and that's what we're going to do with this. We're going to take this horizontal compression, and we're going to turn it into a vertical stretch by just doing math. That's all we have to do is just some math. But look how scary that is initially. So let's play with this thing. Now, if you are studying this, it means you've already had some lessons from Algebra 1 and possibly Algebra 2. I tend to teach graphs first thing, so this lesson hasn't been done with kids yet. In Algebra 2, it's been done in Algebra 1. There's a property out there that looks something like this. It's a times b to the x. And it is a to the x times b to the x. So my little function here, I can apply that property here. This is a and this is b. It's saying I can distribute that exponent to both pieces. So we have 1/4 of a 4 that is squared times an x plus 1 that is squared, minus 3. Now, there's no need for this set of parentheses anymore. It can kind of just disappear. The only reason that master set was there was for that exponent of 2. And I can change that into multiplication, because that's what it is. We should know this by now. If we're freshmen in high school or juniors in Algebra 2, that in parentheses imply the multiplication operation. If we don't, it's time to wake up. Literally, wake up. Now, 4 times 4 is going to be 16, so this piece is 1/4 of 16, which is 4. So I have taken this kind of hideous looking function, and I have removed b by doing math, and all I only have is a. Remember, I said earlier that we would rise 1/4 and run as we run left and right 1. And then we had that stretch idea in there of being 4 times as wide. Or I can't even remember. I'm just so blasted tired. Yeah, something like that. We had a number in there that we had to work with. So, what do we have now? We have now that a is 4. And if we think about this as initial slope, we rise 4 as we run left or right 1 unit. So it's not so bad, is it? Here's my h. H is -1. There's my k. K is -3. And let's get the graphing. So let's see, we can go left 1, down 3. I need most of my grid to be over here. Left 1, down 3. There's my vertex. And my slope is to rise 4 as I run 1. Right there, rise 1, 2, 3, 4. I got to run 1 on the left as well because I'm trying to draw a parabola, right? So if you just do a little math, you can actually make transformations just a little easier. You really can. Now, in the last one, I didn't do this. I'm going to draw this in. That's my axis of symmetry. The axis of symmetry is at x equals -1. My domain, the domain for anything in this particular form, if it's a quadratic, let me say that, is going to be -infinity to +infinity because the graph is running to the left forever and it's running to the right forever. The range of this graph, it has a low y value of -3, and it rises on either side of the parabola to +infinity. And that's the only two I care to do. They're not that bad. Is that a scary looking thing? Yes, it definitely is a scary looking thing. A lot of kids, I think, are terrified of that. It gives them nightmares. It is what it is, though. But anyways, there is a full transformation function of the mother function f of x equals x squared.